Well, hello everyone, and welcome back to Adrian's Digital Basement. For today's video, it's part 2 of the Compaq Deskpro series. If you haven't already seen part 1, I'd recommend you watch that first because we're going to pick up right where that one left off. I'll put a link in the description up here to it if you haven't watched it yet. Alright then, let's get right to it. Alright, well everything is booting on here now with the XT IDE, so I think it's time to put back the original hard drive controller and to put back the original floppy controller, and let's see what's actually working on this thing and what's not working. Slide that card back in. So I'm going to leave this floppy drive connected, and we're going to see if this works with that original floppy card, and the original hard drive controller, which is some Taiwanese card, is back in here. So it does access the disk. We're going to have to go to F2 so it boots off my compact flash and not the hard drive. So we're going to boot off CF card. All right, I have a copy of Checkit on this disk, 720K, because that's all this controller will support. And let's see if this reads it. It's reading it. Now let's see if I can run Checkit off this floppy. It seems to be working fine. So perhaps reseating that card with deoxit did the trick. We're going to know better when I reconnect these original floppy drives. This loaded off this floppy disk. So we know the disk controller at least works with this drive. Okay, the original floppy drives are connected back to the original card. Hard drive controller is in. Everything is screwed back in. Let's power this up. Still have the cleaning floppy in there. Hey, look, we didn't get any kind of 601 error code. It's a good sign. We'll do F2. The top drive is the A drive. So let's go to A. Hey, look, the drive light's on now. We're going to get a general failure, which is expected, because of course there's nothing on here. Let's add a bit more alcohol and put this in the B drive. And we'll go to B. Ah, there it is. It's seeking. There's actually a program called IMD that I love to use. I think this runs on XT class machines. Ah, yes, it does. Good enough. Now we do clean. We're going to do 9 passes and hit enter. And it's a bit hard to see, but what it's doing is it's seeking, this is the head position right now, from 0 track to 40. So it's moving the head back and forth. It's exercising it while the cleaning disk is in there. And with the disk out, you can hear the heads there. That's the head seeking. We're going to exercise the B drive a little bit. This is how the B drive sounds. It's definitely a little bit noisier than the other drive. All right, I formatted this disk on my other computer. Let's stick this in the A drive and let's see if we can read it normally. Yes, that looks totally fine. We'll switch it over to the B drive, and that's working as well. So let's try and copy a program onto the disk. Help.txt to the B drive. DIRB. There it is. Let's put this in the A drive. Help.txt. Hey, it's working. It's reading the disk properly. There's something else that I want to do, and the floppy drives strangely have been working correctly for a while. I really don't know what the flakiness was, but I'm pretty sure it's not these drives. But I really don't like how these two drives look different. And I don't know which of these two is the original, and I've taken the screws out. Let's pop this one out, the bottom one. If the bottom of the drive is to be believed, it's a Mitsumi mechanism here, which actually probably makes sense. This looks very much like the Commodore 64 drive mechanism right here. There are 2 1541 mechanisms, and I'm pretty sure one of them looks just like this. Now let's get this drive out of here. Definitely another 360K disk drive. So this clearly has a Compaq sticker on it, so this would have been the drive that was in this machine most likely. This is a Japanese-made Matsushita Electronics drive, which is also Panasonic. If you recall earlier when I was testing the drives, I have another Panasonic branded drive here. This was one I had in stock, and I was testing with this. It didn't seem to be working correctly, but I think this drive does work. I think the floppy controller was acting up in this machine. The two drives have a very similar faceplate. In fact, I think it's nearly identical. If anything, the power LED sticks out a little further in this original Panasonic one, but it's close enough that at least they match. And even though they're probably different generations, because This one has a much smaller electronics board right here than this top drive. The electronics board is the full length of the drive. But you know what? It's close enough. I'm going to switch the drive rails over to this, and I'm going to put both of these in this machine. Here we have the two floppy drives, with this one being the original drive from the Compaq, and this one being the new one I'm putting in. They both look very similar on the front, but you could see this one is substantially different. They're both made by Panasonic. So I decided to clean these before I put them back in, just lubricating a couple of the points like the head assemblies, but I noticed that there's a problem with this one I'm going to have to fix before I put it back in. Well, unfortunately, I lost the video clip where I talked about the issue I found. But when I looked closely at this drive, I found this lever here had a partial crack in it. And the lever is used to clamp the disk down, so if it broke completely, it would probably render this drive unusable. So, as usual, I decided to break out some JB welds and apply epoxy to this to hopefully fix it once and for all. Alright, it's the next day, and the epoxy has sufficiently cured on this floppy drive. So I found that this lever also had a crack in it, so both of these got the epoxy treatments, JB Weld. I lubricated this drive by adding a little bit of silicone grease right here to this lever, and also I got some lubricant in here and a little tiny bit under this micro switch, and now the mechanism works quite smoothly on this, actually a lot smoother than it ever was. I think the cracking on those levers was probably causing a little bit of unsmooth operation. Okay, so both of the Panasonic Matsushita drives are installed in here. The top one is the OEM one, which has a nice self-eject mechanism. The bottom one, on the other hand, doesn't have the self-eject. And oddly, the top one, you can lower the mechanism even when there's no disc in there, but the bottom one has a little catch for that. So the drives are substantially different, but at least they look pretty similar to each other. I think it looks much nicer now without that Mitsumi mechanism. At least these mechanisms match. 601 error. Oh, whoops. You know what would help with the floppy drives? If I connected the cable. And I don't know if this card is going to be flaky or problematic. I'm going to stick this floppy drive in the A drive, and we're going to do some tests with Checkit. Is disk inserted? It is. And I'm going to do the write test, so I hit yes. All right, that worked on the A drive. I'm going to stick the disk in the B drive and do this again. Thumbs up, that worked as well. B drive is good. So I've really been struggling with the Compaq floppy disk card. It's very flaky where it works for a while, as you saw me doing the testing on Checkit, and then it just stops working randomly. I was off camera copying some files from the B drive to the A drive on the Deskpro, and it just stopped working. That was it. Rebooted, Control Delete, 601 error code, no floppy access whatsoever. So just to eliminate all the possible variables with this machine and these drives, I put this into another computer, different floppy drives, different cable. Didn't work at all, it just said floppy controller error every time I turned on. I spent a little bit of time troubleshooting the card in the other machine, checking for any broken contacts, power rails that weren't getting through, things like that. Thinking maybe there was a broken trace or some other issue, I moved it around in the slot, thinking perhaps there was some type of a physical problem with the board. And normally when you tweak it and bend it like this and twist it, while it's in the machine, you actually have it start working randomly. Unfortunately, after all that, no such luck. The floppy port just does not work at all. Although the LPT port seems to work, well, at least it shows up. I haven't actually tried to print to it. This isn't the first time I've run into intermittent issues with the floppy controller. If you saw my PCjr video, I'll link to it up in the corner here, where I replaced the main floppy drive controller chip, and that actually fixed its intermittent problems. Unfortunately, this Fujitsu chip seems to be the master chip that does everything on this board. Searching these part numbers, I find absolutely nothing on the internet about it, just the fact that it actually existed, but really nothing about replacement parts. I was unable to find a schematic for this board, and without those and this ridiculous master chip here, there's pretty much no chance of me being able to fix this. So I'm throwing in the towel on this board, and I'm going to cut my losses. If you know where I can get a replacement one, let me know, but otherwise, I'm going to move on. So I took a look inside my parts bin looking for 8-bit floppy controllers, and other than the one with the BIOS that I showed in the last video, I can't find any. And I don't want to use that one in this machine because I used that one for testing. So I had an idea of what I might be able to use to run the floppy drives on this machine. And I found this in my spare parts bin. This is a 16-bit ISA multifunction I/O card. It's got serial, parallel, game port, IDE, and a floppy port. And notice it's a 16-bit ISA connector, but I have a feeling that this might actually work, at least for the serial and parallel and floppy, because those are just 8-bit peripherals. IDE is not likely to work since it's a 16-bit interface, but the rest of this stuff may. I also noticed on the back here I wrote no HDD, and if I recall from when I did testing on this, I just could not get the IDE port working. And if I look online for the model number FSIO UC3V12, I was able to find the jumper configurations for this, and yet even though the jumper was configured for IDE, it just wouldn't work. But whether the IDE works or not doesn't matter on this machine. We're using the XT IDE anyways, and all I really needed to do is the floppy port. And actually, it would be a bonus because the original floppy controller had a parallel port. So this has the parallel port, and this also adds a serial port, which this machine didn't even have at all. It had that modem, which I've taken out. So let's pop this in and give this a try, see if this works. So when trying to install a 16-bit card into an 8-bit slot, you just have to make sure that the extra 16-bit connector here clears anything on the motherboard. And other than the no-slot clock in this board, everything else is pretty low profile because nothing is socketed. Which means when we install this card, it just goes right in without hitting anything. And we'll just plug the floppy connector in, just like that. We'll power this up. We'll watch for floppy drive seek. Cool, there it is, it worked. I have formatted disks with files on it in both drives. The computer is booted. Let's check out the A drive. All right, seeking. There are the files. Let's check out B:. It's working as well. There are the files. I'll just do a quick test of the floppy drive with Checkit. I'm not going to write to the disk because there's files on here I actually want, so we'll just do a quick read test. A drive worked perfectly. Cool, B drive worked as well. So when it comes to floppies, one of the issues we're having with this card and that other BIOS controlled floppy controller is the computer prints error code 401, and there it just did it. And I don't understand what error code 401 is because when I check all the documentation, I can't find anything about error code 401. My only hypothesis is maybe the motherboard BIOS complains when the controller chip that's on the floppy controller is the type that supports high density disk drives. That would support 250 kilobits per second and 500 kilobits per second. What's interesting is it doesn't seem to cause a problem. It shows 401 and then boots up. But when I check Compaq's documentation for what error code 401 is, I can't find anything about it. It seems like the first error code on this machine in the 400s is 402, and then it goes on from there. So if anyone has any idea what 401 means on a Compaq BIOS, let me know. But at least doesn't seem to be causing any issues. Now we have a multi-IO card with a serial port. Might as well test the serial port. So here's one of my Wi-Fi modems. Takes micro USB in, and then it has serial out. I just have this cable going to the back of the computer into the serial port. Let's start Procom Plus. I should have done this a while ago. I set it for 50 Hertz. On the high resolution mode, that's the refresh rate, and we got rid of a lot of that flicker. Let's try to connect to a BBS here, rbbs.m. Let's try another one. This one is in Vancouver, BC, outreamer.fsxnet.New Zealand. There we go. It absolutely works. I'm running at 2400 baud between the computer and the modem. That's why it's drying a little bit slow. This is probably the speed that this computer would be going back in the day when it was the original modem. But neat, the serial port, it's working. So just to make sure the onboard memory was working properly, I did the extensive RAM check in Checkit, and everything ran fine, checked out just without issue. The computer hasn't froze, no weird video problems, everything is working fine. So the RAM's working well. I thought it was time to bust out something else I've worked on recently. This is a RAM expansion board that I had designed and had made. It's very similar to the one for the Tandy 1000 that I made, and in fact, I made the same mistake where I had the LS245 backwards. So I built this one up and I just bypassed the 245 entirely because I don't feel it's really necessary. I installed one of these Alliance RAM chips. This is one of the China ones. And the big difference with this is I use an LS151 to do the RAM decoding. Taking a look at the back here, the way this works is there's 512K on this board to be allocated to the machine. And you set the dip switches to disable or enable the different banks. Now this machine already has 640K, so all I wanted to actually use this for is high memory. And I can actually allocate 128K blocks of high memory at a time. So from 640K to 768 and so on. Now I did create on this board a jumper right here, and when you set that jumper, it changes the upper memory from 128K blocks to 64K blocks, and it's on the lower half. When I have these dip switches 8 and 6 set, what that's going to do is going to add 64K right here at the 896K boundary, and also at the 640K boundary. And that's because the upper part of this top bank always has the system BIOS ROM. It starts at F0000. So I'm going to map the 64K into the lower half, and I'm also just going to add 64K right above 640K. Okay, let's pop this in. I did label this where front is always to the front of the machine, so you don't accidentally install it the wrong way. So we'll put it right here next to the modem. I've already pre-set up the Compaq flash card to have the utilities, which I talked about on the Tandy video. I'm using clearmem to clear those upper memory blocks. I'm using the use umbs.sys file. That's going to be the memory manager for the upper memory. And I have DOSMax, which will load DOS 622 into the higher memory areas to give us the maximum conventional memory possible. Just like I said, what's going to happen is loading stuff into the A block, which is the first 64K. And it also loaded command com into the E block, which is that upper one. Let's look at the mem command in DOS. And it's going to show us at 628K of conventional memory free. And that's not bad because I have a few other utilities like DOS key loaded into high memory. We would show 128K total of upper memory, but the way that DOSMax works, loading command com, you actually lose a chunk of that. It's still there, it's being used. It's just command com takes it over and you lose it actually out of there. But the total under 1 megabyte is 730K. Taking a look at the memory map in Checkit, this is actually revealing what we're really getting. So we have high memory from A to B. That is the 64K allocated on my card. We have nothing there. We have a bit of the CGA video card in the B range. This is not high RAM. This is still part of the CGA card itself. Then we have nothing in that spot. We have the ROM. This must be for the hard drive controller itself. And then I have the D00, and this is the adapter ROM for the XT IDE. So the first ROM was the MFM hard drive controller, and then this one is the XT IDE. And then up here in the E to F, this is the other 64K of the high memory. All right, so what you see here is the video card from this machine. And I'm pretty sure that either this connector here or maybe this one over here is probably to allow this card to work in the Compaq Portable with the internal CRT. So these are the monitor connections essentially. Compaq uses their own custom IC. Look at this high density thing here. There's actually a similar one on the motherboard of this computer as well that looks very much like this. Hopefully the chips like this don't blow out, because when they do, these boards are pretty much not usable anymore. I copied a Hercules test program onto my Compaq flash card, and if we run that, it's called test pics. This is definitely not working. It would be showing some high resolution graphics on the Hercules card right now, and clearly it's acting a little funny. So yes, this card, definitely not Hercules compatible. So another question from a viewer was, what does the video output look like from this card to a composite monitor? Now I have the 1084 connected right now to composite, and you notice it's rolling quite a bit. So we have a stable image on this, but we're not getting a sync on here, and that's expected. The monitor is currently configured to output this higher resolution, lower refresh rate signal, which is definitely not NTSC compatible. The 1084 supports 50 Hz refresh rate, but what it doesn't support is the 350 lines of resolution that we're getting on this monitor. But if I switch this computer to CGA on the fly, which I can do on the keyboard by pressing Ctrl-Alt and the less than key, we now get a signal. Both monitors are synchronizing, and I can switch back and forth, and that will cause this to go out of sync. Let's go back to the CGA mode. So I'm currently running this monitor in the high resolution mode, which is the equivalent of the Chroma Luma or S-Video. So the text is very, very sharp right now. This is 100% readable CGA text, and it looks really quite good, but it's going to be monochrome. And here's an overall composite color chart. We got all the different 16 colors. Forest green, not quite. That's kind of like a light yellow, or dark yellow rather, and then that's a light yellow. But the rest of these colors, they look decent. And then here's another chart showing composite color graphics modes. And we got red, which is sort of an orangey color, rose and purple. But when we look here on this monitor, all of the colors are made up of these vertical lines, which again is the artifact color mode. This is pretty much how the Apple II worked, and some other 8-bit computers also generated color this way. This type of artifact color only works on NTSC monitors, as the PAL decoder doesn't suffer from the same problems that would create artifact color, but also enabled computers to very cheaply create color output like this. With DOS, you're able to change the mode on the fly of the different color modes. So if I do mode CO40, that should change us into 40-column color mode. And sure enough, I can see a little bit of color fringing around those letters, which would imply that this is actually outputting a color signal right now. 40-column text is completely readable in color. And if I run a program, it's probably just going to switch back to monochrome 80 columns mode. Oh, so it actually stayed in 40-column mode, and it maintained the color. So you see it's outputting color right now, although edit is not particularly usable because it's really running in the wrong mode. If we switch back to CO80, what it's going to do is it does turn off the color circuitry, so when we go back into edit, it will be black and white. If I recall correctly, the original IBM CGA card does output color mode in 80 columns, and you switch in and out of that by going mode CO80 or mode mono, but I'm not positive on that. Here's the game Thexter, which in CGA mode looks pretty terrible. The colors just don't look good at all, and it could actually have an artifact color mode and it would look a lot better in composite mode, but it definitely does not take advantage of that. Let's take a look at the demo 88 mile per hour. This is a demo that's designed to run the original XTs. It is seeing this machine as 7% faster than it was expecting, and I have turned off the turbo, but it hopefully should still work okay. Let's just see if this works. So this is asking whether I have the new or the old card, and you can configure all sorts of stuff. So I can switch. So it says, tweak these things until you see two seamless color gradients, brightest on the right, ideally, and all blocks should be distinct. So I'm pushing the right arrow, and that's definitely scrolling through some different choices. Although if we look at this one, they all look rather distinct. Everything looks a little bit dim, though. This changes some other thing that makes it all out of sync. Oh, that looks a lot brighter. Okay, that's good. Let's try pushing spacebar to change the CGA model. Old and new. Yeah, none of these look particularly good with new. Old definitely looks a little bit better. So I guess I'm going to keep it on that one because that seems to look the best, but I'm not really sure how these colors are supposed to look. Interesting is, though, is notice how these colors were ones we didn't see on the other test program. I mean, these are a whole bunch of shades of blue and weird orange colors. So we'll hit enter to continue. This demo is great, and if you haven't seen it before, I would go look up the YouTube video to watch it, how it's supposed to look on an actual IBM card. But yep, look what it's able to do. Produce color like that on an original PC. The very first one from 1981, and with a CGA card, can produce color like that and graphics like this demo can do. Some of the print effects are relatively impressive considering how slow a PC is, really. The 8088 is just not particularly efficient compared to 6501 at the same megahertz. And of course, the CGA card is just really designed for not impressive color and also text mode output, really. See, this is what original CGA colors look like, right? Just crap, but look, there we go. A lot better. 1,000 colors on CGA on a 1981 machine. Looks pretty great, and on the monochrome screen, it's okay. But pretty cool looking color on there right now, and nice animation. No idea what kind of tricks they're using to generate 256 colors out of composite CGA, but it's kind of neat that this Compaq graphics adapter is actually compatible enough with the original IBM CGA card that we're getting a really good color representation out of this thing. If you try to run this on the Tandy, the colors look all screwed up and really don't work properly, but you can see here that skin tones are actually, well, somewhat accurate, I guess. This particular effect is not working correctly. These things are supposed to go all the way down here, so there must be a slight incompatibility with the video controller or the way that this card works versus the original IBM CGA card. This is odd. The demo appears to be working, but the music has stopped. It just has a solid beep there. The graphics are still animating, so, oh, it's still running. I have no idea why we just have a solid loud beep. Sorry about the noise. So I think these are the guys that created the demo. It's pretty amazing that it looks that good, actually, on a CGA screen. The sound has stopped beeping, it's just making a clicking noise. And here's the outro. But we got a lot of nice, cool colors showing up on the screen. That's neat for the outro. Sounds like it's actually playing kind of a digital sound representation through the PC speaker, which is possible, but it doesn't seem to be working quite right. This is what it's sounding like close up the speaker. So this is a closer look at the motherboard, and I wanted to show a couple things. There is a socket for the numeric processor in this machine, but check this out. The 8086, it's a -2, which is the 7 or 8 megahertz part. It's soldered on the motherboard. How rude! That means if I want to switch this out with a V30, I'm going to have to desolder that, and it's going to be a pain because of the ground planes and everything. So I'm probably not going to be doing that. I'll just leave it. Here is the BIOS ROM, and you can see that it's in a taller looking socket. That's because it has the battery backed up clock installed underneath it. I think it's possible to read the clock and also set it through a very sophisticated set of read instructions to the ROM chip. Let's pop the ROM chip out of there. All right, so there's the ROM chip, and if we flip it over, yep, you see there's this potted thing here that it's plugged into. See if we can get this chip out of the socket here so we can take a look at what's underneath it. And there we have it. SMT ink. So I think this is the clock chip, and it's underneath here in this potted area is a battery. So when the battery dies, I'm not exactly sure how to hook a new battery up to this. Hopefully someone has figured that out. But perhaps I can cut a couple traces and run a few wires out to an external 2032 battery to power this clock chip, even after the internal battery has died here. Let's try to get this back in here. Okay, it's reinstalled. So one interesting problem is the video card. It was sitting right on top of the chip there. Now that the chip is lifted up, the card actually isn't really in the slot very well. It's a bit hard to see because it's dark in there, I know, but it's not in all the way. So I think I'm going to take the modem out, this card, and I'm going to move my memory card into that slot, and I'm going to move the video card into the slot where the memory card is here. And that will get the video card seated nicely. That could have easily been causing the issues where the screen would just stop working randomly. It hasn't done it in a while now, and the computer's been on for hours and hours, but I think that maybe because this card has just not been seated well, was causing issues. Here are some of the files I was able to copy off that original MFM hard drive onto the Compaq flash, and there's the xtclock.com program. And if we run this, xtclock, okay, SMT, no slot clock, 1986, and let's look at the date, 11/27/2019. I'm still flabbergasted that it's holding some kind of a time. I don't know how to set the clock from the computer back to the no slot clock or update the no slot clock. xtclock xtclock ? I'm running everything I can think about to try to set this clock. xtclock help. Doesn't seem like it accepts any command line parameters because anything we pass it just doesn't do anything. I think it's time for a little Google. Okay, I did a little Googling and I actually found the original instruction manual for the no slot clock. I printed out a couple pages. So like we thought, what's cool is this plugs in under any ROM chip and it doesn't interfere with the operation of the computer. And the software that's written for it is able to communicate with the clock in here by doing special sequences over the memory location where the ROM chip is. It's compatible with pretty much any computer that has normal ROM chips, so that includes these original IBM PC and the clones, but also original Apple IIs as well. It says here that the battery lasts up to 10 years. Well, I can guarantee you that it's been a lot more than 10 years, and it's still sort of working at least. The manual does have all the installation instructions, which I won't show here, but you can look at it yourself if you're interested. But yeah, basically you just pop out a ROM chip. But there's an interesting thing is, while it can work on the motherboard ROMs, it can also work on option ROMs on ISA cards like this. So there's a standard ROM chip right here. Theoretically, if I remove this and put the no slot clock on this card, that would work as well. But we were trying to figure out why I couldn't set the clock, and here's why. There are two utilities that originally came with this. Clockinit.com, which is used for setting the clock, and XTClock, which is what we have a copy of, and that's for reading the clock. So I found the original clock utilities, and I copied them into the clock directory on my other machine. So theoretically, XTClock is a copy of the program that we already have. The byte count looks slightly different, but it's probably a slightly different version. Running XTClock just gives us this, which I assume is setting the date and time correctly. Yeah, it's basically the same. It's odd as the one I copied off the Deskpro originally has a little bit more information, like the version 2.1 and the copyright. So this is probably newer than that one that I copied off the internet. So I'm going to keep this one in the clock directory on the C drive. If you know where I can get a newer version of these utilities, let me know, but this is all I could find. So today is actually December the 15th, 2019. So I'm going to set that. So you set date, and they're showing the correct time, Sunday. So now we got 4:40 p.m., which that's correct as well. And then we're going to run clock init. And it says the XT clock was set from the time and date. So I'm going to turn the computer off entirely. And we're going to power it back on. And we'll see if it loads the correct time and date when I run XT clock. All right, so the date is currently wrong. It says 1980, and of course the time won't be right either. So if we go to utils, clock, and we run XT clock, now we look at the date, and we have December 15th, 2019. Awesome. And the time, 4:41 p.m. Oh man, amazing this thing is working, at least to this extent. Next, I want to take a look at these turbo debug scripts that I worked on in the last video. I had a comment from CGA. He said it would be pretty easy to create a COM file using debug where we could actually change the speed of the computer without needing to run it through the debug command every time. Let's give this a try. First we run debug, and then at the prompt we're going to go N for new, and we're going to do fast.com, and then we press A for assemble. This is where we're going to create the assembly language program. So we're going to move the value of 1, which is turbo, into the address register or the CPU register AL. And then we're going to say out CF, so we're going to send to the IO port CF the contents of the AL register, which is going to be 1 in this case. And then we're going to run int 21, which he says is the DOS interrupt, and then we're going to run int 20, which is the COM exit routine, so it should exit this program back to DOS. And then he says run RCX, and he says you do 8, which is the size of bytes of program. I'm guessing the size is based on the address being used, and it's 100 to 106. So I don't know, I'm just going to do 8, what he says. And then we do W for write, writing 8 bytes. And I'm going to do the same thing quickly for slow mode. So I have 2 COM programs, one to do fast and one to do slow. Taking a look at the power LED, it's green right now, which I think means we're in fast mode. And if I run slow, I'm just going to type the command slow, hit enter, and it's changed to red, which means it's in slow 4.77 megahertz. And we type fast, and there it is, back to fast. And that's pretty cool. It's fantastic. Thank you, CGA. So if you can believe it, I actually got another comment on how to change the CPU speed on this computer based on the code I had showed in my last video. And this one's from viewer Friendly Neighborhood Jesus Freak. He actually compiled a small program using Borland C++ that he wrote that allows you to pass command line parameters for fast or slow that will actually change the CPU speed. And I copied his program onto the Compaq flash card. So CPQ speed. Let's take a look at the source file. So cool, here's the source. He actually put copyright 2020 even though it's still 2019 when we're taking a look at this. And he shows the usage here. You can actually display the current speed or have slow or fast pass to it to control the speed in the BIOS. Now here's where if we don't pass any arguments, it just prints out whether it's slow or fast. There's some error checking in here, very nice. And then if we pass fast, here's where it's outputting the port to CF1 or 0. And the program compiled in a COM file is about 6.5K. So let's try it. Compaq Speed, and I'm going to pass nothing. And yes, that is absolutely correct. It is fast. And just to check it, we'll run my slow command, the one I just created in debug, and then we'll check his program again. And now it's showing slow. And when I run his program with fast pass to it, I actually got invalid parameter. He must have made the command line parameters actually case sensitive. So we'll just try that again with uppercase fast. Invalid parameters. Okay, well, it isn't working. Let me try it with slow. And I'll make it all uppercase. Invalid parameters. Okay, well, thank you, friendly neighborhood Jesus freak, for writing this program. Unfortunately, there's a small bug in your code, but the fact that when I just run it on its own, it is able to detect whether it's slow or fast. It's reading the memory correct. So you're nearly there with your code. For now, I'll just stick to my 8-byte COM files that can do the switching. Well, that's going to be it for part 2 in this video series. In the third part, I'm going to get around to trying to fix up the MFM hard drive that's in here and get that working. There will be a part 4 off in the distant future where I retrowrite this computer and try to get it back to looking original, but that'll have to wait till the summertime. So I hope you enjoyed today's video, and if you did, I'd appreciate a thumbs up, but if you didn't, you know what to do, hit that thumbs down. Subscribe for more videos, there'll be lots more in the future on this and other interesting machines, and put your comments and suggestions down in the comment section below, and thank you very much for watching. Goodbye.